This screencast is going to be about integration by substitution again, but it's part 2. It's going to focus all on the memorized trig functions. One thing you'll need to have with you while you watch the screencast is a page from your packet. It says page 258 and 259 at the very top. It's basically just a list of trig integral problems. We're going to do some as examples, and other ones I'm going to have you try on your own. I think the very first place to start is, before we do integration, is to go back and see how the chain rule affected trig derivatives. So here's an example of something we did way back in Chapter 2, the derivative of the sine of 3x. If you remember, we just directly replaced sine with cosine. So the u value stayed exactly the same, it's still 3x, but I attached a 3 in front. That 3 represented the u prime. So now the answer is 3 cosine of 3x. When we do trig integration, somehow that 3 is going to have to be removed. And that's the integration by substitution part. 3 will now become part of du and get scratched out, just like we did with the power rule. So first thing you'll want to write down, the first thing you should do is just go ahead and jot down the memorized trig integrals. You've seen these before, but when I gave them to you before, they looked a little different. They actually had x's instead of u's. And that's because all of the problems we did before with trig integration, the argument was just plain x. You didn't have to worry about any chain rules or integration by substitution. Now, with that added feature to it, we want to replace the formulas. So all of the x's will become u's, and in the formula itself, you'll see this du here at the end. I'll show you what that means here in just a few minutes. So take a minute, push pause, and jot all those down before you go on. The first example is number 9, the integral of the sine of 2t. What I'm going to do is start by figuring out what u is supposed to be and du. U here is the trig argument, 2t. So du is supposed to be 2 dt. Just like we did with the power rule, I'm going to go ahead and put a 2 at the back and a 1/2 in front to compensate. That means we have a perfect sine of u du problem. The memorized integral for sine of u is negative cosine of u. So I'm going to go ahead and change this to negative 1/2 cosine of 2t plus c. On the next one, the integral of cosine of 3 theta, u is equal to 3 theta. So du is supposed to be 3d theta. So a 3 needs to be back here, and a 1/3 in front to compensate. It's a perfect cosine u du problem. So now I'm going to go ahead and just change it right over to its memorized integral. 1/3 the sine of 3 theta plus c. Here's 2 more. In number 7, it's x times sine of 2x squared. Now remember, we don't have product rules for integration, so somehow this extra x here that's in front is going to have to fit with the du. So I'm going to start by just pretending this is a regular sine problem. U would be 2x squared. That means du should be 4x. Well, I definitely have the x, but it's in the wrong place. It's supposed to be back here. So let me go ahead and rewrite this problem into something that's much more practical. I move the x all the way to the back. With it, I'm going to put a 4 and compensate with a 1/4. That means all of this stuff back here, that's the du that we want to forget about and just get rid of. Sine's memorized integral is negative cosine. So negative 1/4 sine of 2x squared plus c. That extra x at the beginning of the problem that looked like it was going to be more work needs to be used as part of the du. Okay, in the next one, we have this really strange x over 2. But keep in mind that x over 2 is actually the same thing as 1/2 x. So the du is supposed to be 1/2. I can do that. 1/2 at the back and a 2 in front. Again, this problem originally looks like a product rule, but we have a memorized integral, secant times tangent. Secant times tangent's memorized integral is just plain secant. So I'm going to change this to 2 times the secant of x over 2 plus c. So the integral of secant tangent is secant. This next one, I tried to pick out one that would be a worst case scenario. What would be the worst type of problem we could have? This would be a good example of one. It's really actually not that bad. It's not a quotient rule. We don't have quotient rules with integration. Instead, there's just a lot of pieces that are part of the du. If we treat this as just a plain cosine problem and focus just on this part here, its argument, I think you'll start to see where the pieces should fit in. So here, u is the square root of 3x squared minus 6. It's a pretty big argument, but the whole thing needs to be included. That means du should be 1/2 3x squared minus 6 to the negative 1/2 times 6x dx. Now that's a lot of stuff, but it simplifies. The 2 and the 6 should combine together to be a 3x. And that 3x squared minus 6 to the negative 1/2, that's a root on the bottom. So I need all these pieces as part of du. I have most of them. Let me circle them just so you can see. Right there they are. They're even in the correct places. The square root of 3x squared minus 6 is on the bottom, x is on the top, dx is there. The only thing that's missing is that 3. So I'm going to have to put that 3 in there. So let me go ahead and rewrite it here. Put 3 where it's supposed to go and a 1/3 in front. All of this, according to our work, was du. So all of it goes away. The memorized trig derivative, or trig integral for cosine is sine. So this is 1/3 the sine of u. 3x squared minus 6 plus c. What looked like this terrible problem actually turned out to be a lot of things that just went away. Probably the most important thing for you to do for today and the next few days while we work through trig is to have this list memorized. Can't stress how important that is. So make sure you have it memorized, and remember, every time you do a problem, we want to look to see which one of these 6 memorized functions that we have. As soon as you identify which one there is, pick a u and a du, fix it up, and then change it right over into the memorized trig function.